So we've mastered the art of balancing acidic redox reactions. Now it's time to look at redox reactions in a basic solution. These aren't quite as common as the acidic solutions. And to be honest with you, they're like 90% the same thing as balancing an acidic redox. So if you can do that, you should be just fine when it comes to balancing a basic redox. So actually this will be kind of a good review. These two examples at the end of the study guide are actually kind of interesting because they're a little crazy. So let's look at this silver cyanide reaction. And again, often they'll give you some kind of a skeletal equation. Maybe it's net ionic, something like that. We want to balance this reaction in a basic solution. So we want to separate the two half reactions, the oxidation and the reduction. To do that, I like to start by adding the oxidation numbers. So we've got solid silver, that's its elemental form, that's a 0. The cyanide ion needs to be left as a -1 charge. Between the two elements, carbon and nitrogen, nitrogen is closer to fluorine, having a higher electronegativity. So we're going to give nitrogen the -3 oxidation number, which this is going to feel weird, but we're going to leave carbon as a +2. And again, we said it's not necessarily the same thing as the charge that you might find on the periodic table by following some of those trends. These oxidation numbers, in a case like this where it's two nonmetals, are kind of just telling us where the electrons are held closer. You know, we're in a covalent bond between carbon and nitrogen. The electrons are shared, just not shared equally. They'll be closer to the nitrogen, so we give him the negative oxidation number. We've got O2, diatomic oxygen gas. That's a 0, that's its elemental form. And now I've got this silver cyanide ion. We call this a complex ion. It's something we'll talk about second semester. It looks like it could be a little compound, but it's not neutral. It has a charge of -1 overall. So let's see what we got here. The cyanide ion, we know that's supposed to be -1. And within that cyanide ion, we said this is a -3 and a +2. There are two cyanide ions, which would give me an overall charge of -2. We have to kind of work backwards then and figure out what the charge should be on the silver so that this whole particle has a -1 charge. It must be silver 1. And I think we had mentioned earlier in the year that 99% of the time silver is +1. All right, so now let's see who changes. Silver changes. Silver goes from a 0 to a +1. We said oxidation involves losing electrons. If you lose electrons, your charge becomes more positive. So here's the oxidation half. I'll write myself a little note. This is going to be oxidation. It'll be the silver. And then I'm going to add the cyanide, because it kind of goes along with this particle on the product side. And silver cyanide complex ion, -1, or 1-. Okay, so now the other half, the reduction, is kind of the goofy part in this one. Looks like I've got cyanide, carbon stays the same, nitrogen stays the same. Those are taken care of in the first reaction. What happens to oxygen? I mean, you got oxygen on the reactant side, you got to have oxygen on the product side. It can't just disappear. The oxygen is going to get balanced by adding water. Now, they haven't listed that in this skeletal equation, but there may be water or hydrogen or hydroxide. There may be some other particles that will be part of this equation once we get it balanced. So it is just the oxygen for now, and we'll balance it by adding water. That's weird and kind of unusual, which is why I kind of like this one, actually. Okay, so let's balance them. First, let's do the oxidation. We're supposed to balance everything besides hydrogen and oxygen, which we don't have any hydrogen and oxygen. So this one's actually pretty easy. We just need 2 cyanide. And then before I get too excited, I have to make sure that not only the atoms balance, but the charge needs to balance. And if it's not balanced, the only thing I can do is add electrons. I've got a -2 on the reactant side. This entire silver cyanide particle is -1. So in order to get this thing balanced, we're going to have to add an electron. Then each side has a charge of -2. Okay, so now to this goofy reduction half reaction. We've got oxygen, and to balance oxygen, we'd add water. So we'll add 2 waters. This is in an aqueous solution. We've got particles in solution, so there is water present. So we balance the oxygen by adding water. We balance the hydrogen by adding hydrogen ions. Now, I get it. This is a basic solution. But one of the things that we're going to look at a little more next semester as well is the fact that water has a tendency to self-ionize. Water has a tendency to break apart into hydrogen and hydroxide ions. So we'll always have some hydrogen ion present, even in a water solution, a solution that contains water. It may not be the most abundant particle in the solution, but there is hydrogen present. So we're going to treat this just like we would treat any acidic redox. We're going to start by balancing the hydrogens by adding hydrogen ions. So we need 4 of them. There we go. And then finally, we would balance the charge by adding electrons. My product side is neutral, so my reactant side is going to need to be neutral. We need more room. This is the reduction half reaction. I need 4 electrons. There we go. Okay, so now I think we've got the 2 half reactions balanced. We need to make sure the electron transfer is equal between the 2 halves, and then we can add them together. Right now it is not. We've got 4 electrons consumed in the reduction half, so we need to provide 4 electrons from the oxidation half. So we're going to go through and multiply everything by 4. So let's change this to 4 silver. Yikes. We're going to make this 8 cyanide, 4 silver cyanide, and 4 electrons. Now I should be able to add these together and cancel any like terms. We should always be looking to cancel the electrons. 4 electrons, 4 electrons. And the other thing that I'm looking for might be hydrogen ions or water. And those I can't cancel. They are as they are. All right, let's add them up. Let's see what we got here. In any order, 4 silver, 8 cyanide. I'm going to have 4 hydrogen ions and the O2 oxygen gas. On the product side, I'll have the 4 silver cyanide ions. The electrons cancel, so we'll just have the 2 water molecules. All right, so if this was an acidic solution, we would be done. So hopefully that part rang a bell. You know, the oxygen thing is kind of goofy, but you can just add water to balance the oxygen. So here's what makes this different. If it's in a basic solution, there's hydroxide ions present. Hydroxide has an affinity, has an attraction for hydrogen. Hydroxide is negative. If he reacted with hydrogen, we would form water. So here's what we do. We look for hydrogen ions. Bingo. There are 4 hydrogen ions on the reactant side. We're going to add 4 hydroxide. We're going to add them to both sides of the equation. So you look for the hydrogen. You'll add the same amount of hydroxide to both product side and reactant. Now here's what happens. These 4 hydrogen and 4 hydroxide, they're going to react together to form 4 water molecules. So now you got to keep your eye out because you may be able to cancel some water if you have it on both sides. I do have water on both sides in this case, so we can simplify this one more time. We can knock this down to 2, and we can get rid of these water on the product side. Oh, and I forgot, I should have put this in as 4 hydroxides. There they are. Okay, so now let's add this up one more time. And I have my 4 silver, my 8 cyanide, these hydrogen and hydroxide ions are going to simplify, and I will include them as just the 2 waters. I got to add the O2 oxygen gas. And on the product side, I have the 4 silver cyanide. Cn. Cn2 -1. And 4 hydroxides. Don't forget to include those 4 hydroxide ions. If you don't, this thing's not going to balance. I should have the same number of atoms on both sides as well as the same charge on both sides. So let's see what we got. 4 silver, 4 silver, 8 cyanide, 4 times 2 is 8. I have 4 hydrogen ions, 4 hydrogen in the hydroxide. I've got 1, 2, 3, 4 atoms of oxygen on the reactant side. I've got 4 atoms of oxygen on the product side. The atoms check out. Let's hope the charge does too. I have on the reactant side a total charge of -8. Bingo. Product side, -8. So the only thing that's different with this being a basic solution comes right at the end. Once you get this balanced, then you're looking for any existing hydrogen ions. You're going to add the same amount of hydroxide to both sides of the equation. The hydrogen and hydroxide will combine to form water, and then just keep your eye out for any waters that might exist on both sides. And then we'll simplify that. This should check out. Everything balances with the atoms and the charge.